A particle of charge q and mass m is suspended from a point on the wall by a rigid massless rod of length 3 meter as shown as shown. Above the point of suspension, which is this, another particle is clamped which has charge minus q at a distance L from the point of suspension. On slight displacement from mean position, the suspended particle is observed to execute SHM. Find the time period of the SHM. Take kq square as 2mg L square and g as pi square. So let's create a situation when though I'm slightly displacing, but to have a better diagram, I'm going to show it more. Though it's a slight displacement. This comes here like this. And rod is massless. So you don't have to take care about the mass of the rod. I need to find out the time period. Now this is going to oscillate like this. And this will oscillate due to its weight and also due to the force between this charge and this charge which are given. Both charges are equal. So first I need to find out the torque due to the two forces. One is the force of electrostatics, that is between the charges, like this I can mark, and one is due to the mg, and the rotation is happening about this hinged point. I just need to find out the torque due to the two, and then I'll put torque is equals to I alpha, and the moment I'll get I alpha, I'll get alpha. From alpha I can find out the time period. Now let's take this as angle theta. So if I take a vertical like this will also be theta, and this will be equally divided. This is theta by 2, is also theta by 2, theta by 2. Now let's find the torque, total torque. First I'm going to find due to the weight. So this is the line of action of the weight. Okay, see clearly, because torque is always force, which is mg, right now, into perpendicular distance between line of action of force and the point of suspension, means this. So I can also say this as the distance. This also I can make, because this is the sides of rectangle. So I can write this is L, this is theta, this is L sine theta. So L sine theta. Now let's see the direction also. This was the line of action of mg. This was the r. R vector always comes from the hinged point. Then you do r cross f. R goes into f, which is clockwise. So clockwise means negative. I can take it a minus sign. You can also write for the time being k cap. Now the next the force is the electrostatic force, which is going in this direction. Can you see that? See. Now this is the force, and I need to take perpendicular distance from the hinged point to the line of action of force, this line. So if this is L, this is theta by 2, this line, this becomes L sine theta by 2. Okay. So this is theta, and this I've got theta by 2, which is the half of this angle. Now I can use the trigonometry to get this length, L sine theta by 2. So the force is Fe, electrostatic force, into perpendicular distance, that is L sine theta by 2. This entire should be written as I alpha. Okay, two forces only, and both the forces are producing a torque. Now write it carefully. I did not see the direction. This is R. This is the force upside, because this is minus charge given to us in question. This is plus charge. So force is going this direction. So R cross F will be anti-clockwise. So it will be plus K cap. Now just to have the direction, then you can remove the K cap also. Now mg L sine theta, you can take a minus sign, plus. What is electrostatic force here? It is kq square by this distance square. How to find this distance? This is L, this is theta by 2, this is L cos theta by 2. Okay, and both together will be 2L cos theta by 2 square into L sine theta by 2 is equals to I alpha, where I will be taken as ml square, because rod is massless. We are not taking the moment of inertia of rod, only this ball, and it is singular particles. For single particle is mass into radius of circle. So ml square it will be there. Now let's solve this first. I'll stop writing torque here. because it's already written. Let's calculate. And they have given something, kq square can be written as 2 mg L square. So I'll write it now. So kq square is 2 mg L square into L sin theta divided by 2 divided by 4L square cos square theta by 2 minus mgl sin theta equals to ml square alpha. Okay, these are lengths. Okay, so now we can start solving. Remove this L square first. I've removed it. So I have now L here, L here, and L. So one L can also be cancelled from here. Mass can also be removed from here. Okay, so what are we left with? 2g sin theta by 2. Okay, so we have one can be cancelled, 2 also. So we have g, and all L are gone. G sin theta by 2 minus divide by 2 cos square theta by 2 minus g sin theta is equals to L alpha. Okay, so we calculate here by 2 upon 2 cos square theta by 2 minus g sin theta. G sin theta is equals to L alpha. Now I can write it as g, I can take common. This sin theta by 2 upon 2 cos square theta by 2 minus 2 sin theta by 2 cos theta by 2. Like this I can write. Now since angle is given very small, so I can take sin theta by 2 as theta by 2 and cos theta by 2 almost 1, because angles are very small. So this keeping the substitution, we get theta by 2 divided by 2 minus 2. This is taken as theta by 2 as 1. So L alpha is equals to, this is theta by 4 minus theta. So I'll get 3 by 4. From G I left it actually out. So alpha will be minus 3 G theta by 4 L. So we got that expression minus omega square theta for time period. That means omega is square root of 3G by 4L and time period will be 2 pi by omega. That is the answer to the question. So you can also take it out. It will become 4 pi L by 3G.